start of mission procedure. The loco pilot has to start a train mission when the train is awake. When a mission is ended and when a slave engine becomes a leading engine. The start of mission ETCS level selection. In level 0, that is unfitted mode, the condition required is as under: onboard computer is switched on. Onboard computer is serially communicating with driver-machine interface and is indicated by communication status flashing on driver-machine interface. Now the system is in the standby mode. The train is at standstill and the speed is displayed in driver-machine interface as 00. Press the start button. Press the level 0 button. Again press the start button twice and ensure that the shunt request icon lights followed by end of authority icon. Press the start button and the system will switch to level 0, that is unfitted mode. Press the unfitted mode button and check the level transition icon and the maximum permissible speed. Full supervision, that is FS mode scenario. On completion of start of mission, the system is switched on to level 0 and unfitted mode. When the train passes the first switchable ballast group, the trackside data required for full supervision of the train is available to the onboard computer and the system changes to full supervision mode level 1. In full supervision, overspeed scenario. TPWS system continuously monitors the actual speed of the train and compares the same with the maximum permitted speed at any location of track section. System provides audible and visual warning whenever there is deviation with respect to the maximum permissible speed for corrective action by the loco pilot, that is, if the actual speed is exceeding by less than 5 km per hour, then system provides overspeed indication for corrective action. If the actual speed is exceeding by plus 5 km per hour, then system initiates the service brakes automatically. If the actual speed of the train is exceeding by plus 10 km per hour, then system initiates emergency brakes automatically. This action is registered by emergency brakes counter. Infill ballast scenario. Advantages of infill ballast. It is an additional ballast placed at a distance of 500 meters approximately in rear of a signal in advance connected through the data cable and is used for increasing the section capacity. Used for updating the movement authority whenever the signal in advance changes its aspect. Provision of this ballast improves the section capacity by updation of movement authority whenever the signal in advance goes for higher aspect before the train passes the infill ballast. Provision of this ballast is also very useful whenever the signal in advance changes its aspects to the most restrictive aspect, that is, reduction in moment authority. Infill ballast scenario. Three cases are discussed as follows. No change in movement authority at infill ballast location. On passing the signal S1, train received the movement authority up to signal S2. When train passes the infill ballast of signal S2, there is no change in movement authority as signal S2 remained at on condition. Detailed scenario. The moment authority for the train is up to the next stop signal. As the train passes the switchable ballast, the moment authority is received and maximum permissible speed is displayed on driver-machine interface. After traveling a specified distance, the target distance indicator appears on the DMI. The portion lit in red indicates that the distance up to the next stop signal. After traveling 500 meters, train is passing an infill ballast connected with the signal in advance, which is still showing red aspect. Hence, there is no change in previous moment authority at infill ballast location of signal S2. As the train is approaching a stop signal at on, the maximum permissible speed gets reduced with the target distance. Release speed curve, which is orange in color, indicates 20 km per hour that appears on the speed curve. It permits the loco pilot to reach up to the foot of the signal cautiously. Change in movement authority due to signal in advance change to higher aspect at infill ballast location. On passing the signal S1, train receives the movement authority up to signal S2 as signal S2 is at on position. Prior to reaching the infill ballast of signal S2, the aspect of signal S2 changes from red to yellow aspect. When train passes the infill ballast of S2, the updation of movement authority is transmitted to onboard cab equipment. The updation of movement authority shifts the braking curve up to signal S3. As a result, train passes the signal S2 with maximum permissible speed, thus helps in improving the section capacity. Detailed scenario. The system receives the movement authority for the train up to the next stop signal S2. After traveling a specified distance, the target distance along with release speed curve appears on the driver-machine interface. Before passing the infill ballast of signal S2, the aspect of signal S2 changes to yellow. As soon as the train passes the infill ballast of S2, following indications will disappear on the driver-machine interface, that is, target distance disappears, release speed curve indication disappears from maximum permissible speed curve, and it indicates updation in movement authority. Change in movement authority due to signal in advance changes to most restrictive aspect, that is red. On passing the signal S1 with green aspect, train receives the movement authority up to signal S3 as signal S2 is having yellow aspect. Prior to reaching the infill ballast of signal S2, the aspect of signal S2 changes to most restrictive aspect, that is red. When train passes the infill ballast of S2, the reduction or shortening of movement authority is transmitted to the onboard cab equipment. This reduction in movement authority causes the shifting of brakes curve up to signal S2. Detailed scenario. The system receives the movement authority for the train up to the signal S3. Before passing the infill ballast of signal S2, the aspect of signal S2 changes to red. As soon as the train passes the infill ballast of signal S2, the following indications appear on the driver-machine interface, that is, target distance, reductions in maximum permissible speed curve to reduce the speed of the train for safe movement, release speed curve appears to reach the signal S2 with safe speed. EOA, that is End of Authority Override Procedure. This mode requires written permission guided by general and subsidiary rules. End of authority, that is EOA override procedure, is used under specific degraded conditions: signal failure, track circuit failure, points failure. When the train stops at the foot of the manual signal at on position, EOA icon will lit on the driver-machine interface. Loco pilot presses the EOA override button, then signal pass with authorization icon along with staff responsible mode will lit on the driver-machine interface. Maximum permissible speed curve, that is 15 km per hour, will appear on the driver-machine interface and allows the train to pass the manual signal at on, that is red. When the loco pilot passes the manual signal at on and following changes appears on the driver-machine interface, signal pass with authorization icon disappears from driver-machine interface. Permissible speed changes from 15 km per hour to maximum permissible speed of the section. Staff responsible mode continues up to the next switchable ballast location. Thereafter, system enters into full supervision, that is FS mode. On-site mode. On-site mode is used to pass an automatical signal at on position, calling on signal at off. The train stopped at the foot of the automatic signal at on. After following general and subsidiary rules, that is G and SR, train can pass the automatic signal at on, then system enters into on-site mode automatically through trackside information only. Once entered into on-site mode, system requires acknowledgement of the loco pilot within 5 seconds. If the loco pilot does not acknowledges within 5 seconds, the service brakes shall be applied till loco pilot acknowledges. System shall remains in on-site mode up to the foot of next stop signal. On-site mode indication shall remains lit until the train passes the switchable ballast connected to the next signal. On-site mode indication reminds the loco pilot that he should proceed ahead at the specified restricted speed as per general and subsidiary rules. SPAD, that is signal passing at danger, manual. Whenever a train passes a signal at on, system applies emergency brakes to stop the train with continuous audible emergency buzzer. Emergency braking will be registered in emergency braking counter. Trip icon lights on driver machine interface. Traction control indication will cut off, that is no indication. After the application of emergency brakes, system shall allow the train movement only under staff responsible mode. Following procedure is to be followed for staff responsible mode. Loco pilot has to acknowledge the trip icon come button. Acknowledgement of trip icon stops the buzzer and post-trip icon will appear on driver machine interface. Loco pilot shall press start button twice. Then staff responsible icon appears on the driver machine interface. Loco pilot acknowledges the SR icon come button, then the system allows him to run the train under staff responsible mode. Movement authority on the driver machine interface is indicated as maximum permissible speed of the section. In staff responsible mode, loco pilot is only responsible for the train working. Reading the telegram. Reading the telegram saved in the volatile memory of ballast and LEU via air gap. Place the ballast programmer and verifier tools on the ballast. Set the switch at V, that is for verifying position. Then ballast programmer and verifier reads the telegram saved in the volatile memory of ballast and LEU via air gap. At the end of preliminary steps for working with palm top, the air gap interface window with 5 options will appear on the screen of the palm top. Read C5, write ID, write TLG, read AG, verify AG. Select the read AG in the air gap interface window. Telegram will appears on the screen of the palm top defined by 1023 bit and user bit. Log file is created at the end of read process. Verifying the telegram. To verify the telegrams in the ballast via air gap and comparing it with the file preloaded in the palm top. Place the ballast programmer and verifier tools on the ballast. Set the switch at V, that is for verifying position. Air gap interface window with 5 options will appear on the screen of the palm top, which are read C5, write ID, write TLG, read AG, verify AG. Select the verify AG in the air gap interface window. Telegram will appears on the screen of the palm top defined by user bit and outcome of comparison as preloaded in the palm top.